right, let's talk about adding and subtracting fractions with like denominators. So I'm going to look, let's start with this example. 2/7 plus 3/7. Okay. So remember, one of the ways to interpret this is the unit 1/7. I can really just think about them as a unit. 7th. Right. And if I just think about this a unit as feet or cups or whatever it is, right? You just add and keep the units. And so that's just 5/7, right? Which, again, we can switch back to our fraction form like that. So that should make some sense. Another way to look at this is, let me do a little bar diagram. And I can do, there's 2/7, and I'll use other color or different cross hatching, right, to go the other direction. Right, and this shows, again, 5/7. Right. Now again, if the denominators are the same, you've got the same thing. So the only thing that you might have to deal with is if these things get larger than 1, you have to think about things a little bit differently. You can either make them an improper fraction and switch to a whole number, or interpret things in different ways. And I'll show something else a little bit later. Okay. Let me talk about subtraction. So let's say I have 4/5, say minus 1/5. All right. Okay. So I'm going to show this a couple of different ways. One, let's do a model. So again, I'm going to do fifths. And I'm going to show 4/5. Okay, so that's a little bit like, what I'm going to be doing is a sort of maybe a takeaway. This would be a takeaway interpretation. Okay, where I'm just going to be hopefully clearly removing a piece. This is a little bit hard to show with both shading and stuff, but then I'm left with what, 3/7. 3/7. Okay. All right, another really nice interpretation is the number line. So 0, 1, and I'm going to break into fifths. And I'm going to start here. Okay. This is the counting down interpretation of it, but all I'm going to do is hop down a fifth to land on, why did I put sevenths there? I'm getting this stuff all mixed up. 3/5, right? So I'm doing that. Okay. The other way to do it is the counting up method would start here. So this guy is counting down. I'm going to go ahead and put the other interpretation on there, which is counting up, which remember starts at 1/5 and count up until you get 4/5. So boom, boom, boom. I land on 4/5, and there's 3/5 there. So that those both show the same thing in two different ways, right? Counting up method. And all of these are important to be sort of have as an understanding of fractions, and when you're sort of teaching like the really basics of this stuff. Like that. Okay, so what does that just show again? So if we have A over B minus C over B, we get A minus C over B. So that is the sort of algebraic form. Let me also show some things with mixed numbers here. Let's say I have 3 and say 3/5 plus 2 and 4/5. And I want to add that. So first of all, I'm going to do a couple of things with this. I'm going to do a model. So I've got 3 and then fifths. So I'm going to break that into fifths and then half. And then I have 1, 2, and boom, 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 boom. 3/5 and 4/5, right? Okay. And then let me go ahead and maybe shade those as well. Right. So a couple of things you can think of is, yeah, I've got 5, right? And 1, 2, 3, 4, 5, 7/5. Okay. Which I can also think of, and you can do this a couple different ways. I can actually move a pi piece from there to there, and then I have 1, 2, 3, 4, 5, 6, and 2/5 left. Right. The other thing you can do, right? So it's just 6 and 2/5. So I don't need to put the plus. And then the other thing you could do is you could just change that into a mixed number and then add like that. Okay, another way, again, this is really nice on the number line. So let's see, I want to go to 7 here. So let me be careful, making this pretty good. So 1, 2, 3, 4, 5, 6, 7. So 3 and 3/5. So 1, 2. I'm going to do fifths there. Let me go ahead and do fifths on all of these. Okay. I'm going to start 3 and 3/5. Lands right there, right? And I'm going to do 2 and 4/5, right? So I'm going to do, so a couple things we can do. You can split up 4/5 and do it 2/5 and then 2 big hops and then 2 more fifths to land you at 6 and 2/5. That's probably easier than thinking of 2 big hops and then 4/5 of a hop. But that is another way of doing that. Right, so I got 2/5, 1, 1, and 2/5. Right, and that lands at 6 and 2/5. Got that. Okay, let's do subtraction of some mixed numbers. Right. And let's do 4. Let's do 4 1/4 minus 1 3/4. Again, I'm going to start with an area model. So 1, 2, 3, 4, and 1/4. Okay. And I want to take away, I'm thinking about this as a takeaway, again, interpretation. I want to take away 1 3/4. Well, all right, I can easily take whole one away. I've only got 1 to take away there, but I can just take this guy, right, and carve it into 4 pieces. Right? And maybe I'll shade just to clearly say we've got all of that. And now I want to take away 3 pieces with that. So what am I left with? I'm left with 2 and 2/4, right? Which again we can write as 2 and 2/4, which we can write as 2.5. Let's do a number line of this as well. 3, 4. That's not very. There we go. 4. So 4 1/4. I'm going to start with here. And there's, again, a couple different ways we can do this. We can do counting up and counting down. So this would be the counting down. So I want to go down 1 and then 3/4. 1, 2, 3. And that lands at 2 and 2/4, or 2.5. All right, so this is counting down. And the counting up method would start at 1 3/4, and I want to count up until I get to 4 1/4. So I'm going to count 1/4, and then I'm going to do 1 hop, 2 hop, and 1/4. So 1/4, 1 1 1/4. The total number of hops is 2 2/4, which is the same as that. Okay. Right. So, along with that, right, you can also think about this as 4 1/4 is, in maybe a similar way to this, is the same as 3 plus 1 plus 1/4, and I can write the 1 as 5/4, right? And then minus 1 3/4, right? And I'm subtracting 2 and 2/4, right? So this is like unbundling, like we had before, but we're unbundling in terms of fractions, not in terms of units of 10. Okay, so that's adding, subtraction, both fractions and mixed numbers, as long as the denominators are the same.